Hey there, algebra. We are in Unit 2, Lesson 18. You guys just took a mid-unit assessment on lessons 1 through 17, and those all have to do with equalities. Get my pen going. So lessons 1 through 17 were all equalities, which were linear. We did just lines, we did systems, okay? But they were all equalities, which means they were equal signs. That's an equality. Now we're doing inequalities, all right? So we're going to start with just situations with inequalities, just like we did with equalities. We did simple situations, and then we moved on to systems of inequalities. So here we're going to do inequalities which are greater than or equal to, less than, or less than and equal to. These are all equalities as opposed to, these are all inequalities as opposed to equalities, which are all equal signs, all right? So let's use inequalities to represent constraints in situations. So match each inequality to the meaning of a symbol within it. So here, if I read this, this says H is greater than 50, okay? So that would be matched with this. Okay, how about this one? If I read it, I read left to right, this says H is less than or equal to 20. Okay, less than or equal to 20. Here, this says 30 is greater than or equal to H. Okay, I actually try to read this H is less than or equal to 30. I like the variable first. But what we read here is 30 is greater than or equal to H. I don't like that one, okay? Because those match, but this one would read H is less than or equal to, just like the other one. Okay? It's okay. All right, is the number 25 the solution to any of the inequalities? Which ones? So, is 25 greater than 50? No. Is 25 less than or equal to 20? No. Is 30 greater than or equal to 25? Yes. We could also say it here. Is 25 less than or equal to 30? Do you see how they're true no matter which way you do it? Okay. Now, is 40 a solution to any of these qualities? Is 40 greater than 50? No. Is 40 less than or equal to 20? No. Is 30 greater than 40? No. Is 40 less than 30? No. It's not any of them. All right, is 30 a solution? Is 30 greater than 50? No. Is 30 less than or equal to 20? No. Is 30 greater than or equal to 30? Yes, 30 is greater than or equal to 30 because it's equal to. So we can say C for that one too. Okay, feels a little weird, but it's right. If you talk out loud to yourself, it will hopefully make sense, right? If you read it like you would read a book, it would hopefully make sense. Yep, we got them. Okay, just read it like a book. All right, continuing our warm-up. How do you know whether each of the numbers, the 50, 20, and 30, is a solution to the inequality? Okay, we substitute, just like it's saying, we substitute H equals each one of these things and read. Does it make a true statement? Does it make a true statement, right? Beyond the different symbols, how are these equations different from the inequalities in one variable? Beyond the different symbols, how are these equations different from the inequalities in one variable? I don't know how to read that. Sorry. Beyond the different symbols, how are these equations different from the, I'm going to think this is supposed to say different from the equalities in one variable. Yeah, because that would be the different symbols. So this question's asked incorrectly. So beyond the different symbols being these, how are the equations different? For our inequality equations, the solutions are a range of numbers. Okay? Our solutions, they will be a boundary. Okay, you will not get no just one solution. Your solution is a range, a whole bunch of values. Many, many different answers can make your statement true, okay? All right, so let's dive right in. Planning the senior ball. Seniors in a student council of a high school are trying to come up with a budget for the senior ball. Here is some information they have gathered. Last year, 120 people attended. It was a success and is expected to be even bigger this year. Anywhere up to 200 people might attend. There needs to be at least one chaperone for every 20 students. Ticket price cannot exceed $20 per person. The revenue from ticket sales needs to cover the cost of the meals and entertainment and also make a profit of at least $200 to be contributed to the school. All right, that's a lot of information. I believe you have that information in front of you because I'm going to get a new page, just like normal. All right, so here are some inequalities the seniors wrote about the situation. Each letter stands for one quantity in the situation. Determine what is meant by each letter. Okay, I left a blank just in case I needed it. All right, so let's do this. Right here, what does this one represent? T is less than 20. T is less than, this should be or equal to 20. That's what your book says. Okay, that means that the ticket price is less than or equal to, my goodness, or equal to $20. Okay, it was one of the things the seniors talked about. In their blurb, it said, ticket price cannot exceed $20 per person. So the ticket price is less than or equal to $20, right? What's this next one? 120, P, 200. So 120 is less than P is less than 200. Okay, or P is in between 120 and 200. If I read the revenue from ticket sales, nope, that's not it. Last year, 120 people attended. It was a success and it is expected to be even bigger. Anywhere from 200 people might attend. So this right here would say between 120 and 200 people are expected to attend. And then P is the number of people attending. which I don't think I did for the green one. I didn't do the letter. So T equals the ticket price, which we inferred. Good job. Okay, how about this one? PT minus M is greater than 200. How about PT minus M? That's the number of people times the ticket price, which we already defined, minus, what is M? Cost of meals and entertainment. That'd be the cost, equals revenue. Okay, it's not really what the problem's asking us, but I needed to define all those things before I could figure out what it means. So revenue must be greater than, can't spell, $200. Okay, the revenue must be greater than $200. The total amount collected from ticket sales in dollars minus the cost of meals and entertainment must be greater than or equal to $200. Okay, so that would be the number of people, the ticket price, and the cost of the meals, entertainment. All right, cool. I'm all out of fun colors, so we'll go here. C is greater than P over 20. Well, that would be the chaperones so the number of chaperones must be greater than the number of people divided by 20. The number of chaperones must be more than 1/20th of the number of people attending. Cool. So those are our constraints. With inequalities, we need to come up with values that fulfill all of those constraints. So our answers can be a range of answers, but getting to the answers can be somewhat more complicated. But that's what we're learning, so it's okay. Sorry, this program every once in a while skips to the beginning. It's quite annoying. All right, how many chaperones are needed if there are 120 students? We had this equation. C is greater than or equal to P over 20. So C is greater than or equal to 120 over 20. C is greater than or equal to 60. 6. Just 6. So we need at least 6 chaperones. 6 or more chaperones are needed. Cool. Is that question in your... I don't know where that question is in your... Okay, there are some other questions I want to ask, so I think we're missing some. All right, so it might be in the Are You Ready for More, but I think it's pretty important. So if I said T must be greater than or equal to 0, what does that mean? And if you remember, T is the ticket price. It wasn't a constraint that we came up with early on, but very important. Ticket price, what this says is ticket price must always must always be positive. No negative ticket prices or you lose money. All right, so negatives are bad in a lot of these real world problems. We would call that a natural constraint, one we don't really have to talk about, but it's very important. You know, we could say that for most of them. The amount of people that attend should be greater than 0. Nope, but we already have a constraint that it has to be between 120 and 200. I assume M is going to be positive. That's the cost for meals and entertainment. Things like that. I do like this program better because of that. Oh, it didn't work. Oh, I thought it would erase it. Let's try again. I think I did it wrong. There we go. All right, so let's move on. I don't know why it does this. Okay, so elevator constraints. So an elevator, car, and a skyscraper can hold at most 15 people. And I always underline things or highlight things. If you guys ever ask me to come to your desk for help, I'm usually underlining things. For safety reasons, each car can carry a maximum of 1,500 kilograms. On average, an adult weighs 70 kilograms and a child weighs 35 kilograms. I guess we should keep on going. Assume that each person carries 4 kilograms of gear with them. Write as many equations and inequalities as you can think of to represent the constraints in this situation. Be sure to specify the meaning of any letters you use, and we would avoid using Z, M, or G. Trade your work with a partner. I would love to do that, but we're not gonna. Trade your work with a partner and read each other's equations and inequalities. Explain to your partner what you would think their statements mean and listen to their explanation of yours. Make adjustments. Okay, we're just going to talk through it a little at a time. You have this information in front of you. I'm going to get a new slide so that I can work. There we go. Okay, so I need that page. An elevator and a skyscraper. What about the people? If I say P is the number of people. I think it was a 1,500 kilogram max. Looking at 15 people, sorry. So the amount of people must be less than or equal to 15. So that is one constraint. That right there can be read, P must be less than or equal to 15, where P is the number of people in the elevator car. All right, now let's do A equals the number of adults, and C equals the number of children. We could say that A plus C must be less than or equal to 15. Okay, that means the total people have to be less than or equal to 15, and now we've put in values for A and C. We can take this another step and say W must be less than or equal to 1,500, where W, sorry, that's in a different order is what I've done. Let's keep everything pretty organized. So W equals total weight. So with that, we can say A plus C must be less than or equal to 1,500. But I think I'm missing something. I think I'm jumping ahead of myself. Really, we just want to say the weight must be less than or equal to 1,500. It's just a constraint, okay? Not a big deal. But we can definitely take that further. We know, what is the total weight? What is the total weight? Let's see. How much does an average adult weigh? 70 kilograms. So 70 times A plus 35? Yep. 35 times B. Oh, but we need their gear. 4 kilograms per person. And that should be C, not B. So this says the total weight in the car is going to be 70 kilograms per adult, 35 kilograms per child. I wrote B again because I am really with it. Plus 4 kilograms of gear per adult, plus 4 kilograms of gear per child. That's going to be my total weight, but we've said that the weight has to be less than or equal to 1,500. So we know that 1,500 has to be the biggest, and then all of this stuff has to be smaller than it. And at this point, if you had written 74A plus 39C, it would be equivalent. Okay? Totally equivalent. I actually prefer to write things like this. I really like the equal sign to be, or the inequality to be on the right. Pac-Man is eating the 1,500. Pac-Man needs to continue to eat the 1,500. So that is how I prefer to write the equation. All right? So that was, the problem said, write as many equations and inequalities as you can think of to represent the constraints in the situation. Be sure to specify the meaning of any letters that you use. Question 2 said, trade your work for cool. We're going to skip question 2. And then rewrite your equations and inequalities so they would work for a different building where an elevator car can hold at most Z people. Each car can carry a maximum of M kilograms, and each person carries G kilograms of gear. Sorry, the M is each car can carry a maximum, so we're going to say M, maximum weight. All right, so we're going to rewrite each equation. Let's do it. So we know here P is less than or equal to Z. Not too bad. And here we have A plus C is less than or equal to Z. And here we have W is less than or equal to M, which means W is equal to 70A plus 35C plus 4. We're going to say GA plus GC. And I'll fill in the rest of it. And now we can't use 1,500, we have to use M. 70A plus 35C plus GA plus GC. Here, I can't do that anymore, so I have to say 70 times, let's see. Nope. So I'm going to take 70A and GA and say 70 plus G times A plus 35 plus G times C is going to be smaller than or equal to not 1500, but M. That last one was hard. Not impossible, but hard. Okay, so we replaced everything with what it wanted us to. Oops. C above. All right. So, what are some advantages and disadvantages of representing constraints as inequalities? It actually gives us more flexibility in our math. Okay, we definitely get more flexibility. Inequalities are easier to use for descriptions. So those I think would be advantages. Plus would be advantages. Negative, sometimes I find that it's hard to wrap my head around what we're trying to do. I don't know if you feel the same way. It's hard to wrap my head around the greater than or less than and which way am I thinking. Okay, etc. It's just hard to wrap my head around, especially when you read things one way or another. What advice would you give a student who might just be learning to write inequalities to represent constraints? My advice would be to read them out loud, left to right. And Pac-Man, oh, what was that? Let's see. Pac-Man always eats the bigger. So it's always going to eat the greater. Okay? So if it were like this, it doesn't like when I write out here. So Pac-Man's going to eat the greater. So what's on this side is the less than. Okay, that's always going to be greater. So on this side, it would be the less than. Pac-Man always eats the bigger of the two values, always. So I can write inequalities that represent the constraints in a situation, and that's it. All right, good job.